My name is Michael Morley. I'm your instructor for Mathematics 108, which is trigonometry. And as you know, we are currently having some trouble with our eLive. And what I thought I would do is I would just create a lecture for you guys and put it up on Blackboard. And you get to watch this the day before, and then we'll come into class and discuss on the telephone or whatever communication that's available some of the solutions to these problems. I think in math it really helps if you can see a nice big board and some demonstrations going on. So this was arranged rather hastily, and I'm going off the cuff. So today what we're really going to talk about is angles and their measurements. And the first thing, the idea that I'd like you to get used to is remember the coordinate axis. Here's your x-axis. Here's the y-axis. I'm going to draw what's called a unit circle right now, or the best approximation as I can make to one. And the unit circle is going to play a big deal in the beginning of trigonometry here. And this isn't so bad. Trust me, my drawings get much worse than this. What do you know about a circle and degrees? Okay, so you know that there are 360 degrees, and this is the little circle there means degrees, 360 degrees in a circle. Well, what does that really mean in terms of this unit circle? This is the 0 point right here. And if you're counting around here like this, going counterclockwise, we're going to count positive measure. Oh, that was good. So this is the first thing to kind of be aware of. There are 360 degrees in a circle, and going from left around here is how you're counting them out positively. Incidentally, if you start off, different color. So what would happen if you went down this way? Well, this would be minus 90 degrees. And I'll put this up here. This is minus 180 degrees. This is minus 270 degrees. And this is minus 360 degrees. And you might be asking yourself, what is the advantage of deciding a direction as positive and a direction as negative? And you should also notice that minus 180 degrees and 180 degrees are the same place. If this is a place where something lives, this gets you to the same house. The same as 270 and minus 90, 0 and 360 and minus 360 are all the same place. Minus 270 and 90 in degrees are the same place. This might seem confusing why we would do this. What I'd like you to think about is the real number line, because ultimately that's going to tie in here. Suppose that we do this. Now we're not going to use degrees. Eventually we're going to use radians, but for the moment I'll just write this in as degrees so we can see this. Suppose this corresponds to the 90 mark. This is 180, 270, that would make this 360, goes on and on. This would be minus 90, minus 180, minus 270, minus 360. Think of this number line as being wrapped around itself an infinite number of times, and that's what this kind of idea is going. Said a mouthful there. I'm from Minnesota. I've been told that I speak too fast. If I drink too much coffee, it's even worse. It's just the way that it is. I'll try and keep it in mind. So when you get your books, the first thing that they're going to talk about is an initial angle and a terminal angle. And this is what's called jargon, which is just a specific lexicon for any kind of endeavor. Banking has their own jargon, physics has their own jargon, and in mathematics, when we're talking about an angle, so here's some angle. Here is the angle, let me see how it's done in your book. Actually, let me say a couple things. I'll probably do this. This is alpha. This is beta. This is gamma. These are Greek letters, and They're often used for angles, even though in your book they use capital A, B's, and C's oftentimes. I'm classically trained and I use these. So if you see these start showing up, don't worry about it. But for right now, so we're going to call this angle alpha. So this is a angle alpha. And so this is corresponds with the x equals, or the x-axis, which in fact on the coordinate grid is the line y equals 0. Hopefully everybody remembers that from algebra. So what we're doing is we're taking this angle and we're superimposing it on here. And this is where we're going to do our analysis from. And this is alpha. This is called the initial side. And this is called the terminal side. T-R-I-M-I-N-A-L. Let me guess, if I spelled that wrong, I'm going to have to send myself home. T-R-M-I-N-A-L. 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 So right away you might be thinking, hey, this guy can't spell. How smart can he be? Truth is, a lot of mathematicians don't spell very well. So what does it mean, initial and terminal? Really, if you can think of this, and incidentally, this is a ray. It would be more proper to put it like this. This angle has specific lengths. I'll explain a little more what I had actually drawn later. So what I did was I took two sticks and I opened them up like this, and I made some angle. This is the initial side. This is the terminal side. Just as an aside, how was what I had different? What I had was this with this little arrow. These are called rays. And this is in the book somewhere. Incidentally, I will probably overteach you. I have a habit of doing that, but it'll be good for you in the end. What it means is the little arrow means it keeps going on and on. As it is, this angle right here, these have specific lengths, and that will be important. Now, how does this notion of initial and terminal angle come into play with what we showed for the unit circle? And so here's our coordinate grid again. This is the x-axis, and this is 0 degrees. I guess we won't do it twice. This is 90 degrees. This is 180 degrees. This is 270 degrees. Okay, so here is our initial angle, and it may be the case. So it's possible they're going to do this. Straighten it out, put the initial side down on the x-axis. So here's your initial side, and then you're going to measure out 30 degrees, and you're going to put this here. So you're going to translate this over. So if they say, what is the terminal side of a 720 degree angle? Basically, they're asking you to start here, zip it around a couple times, and figure out where it lands. That one was kind of easy because 360 goes into 720. Let's do something a little less easy.